Okay, problem number 8. Problem number 8. Here we're looking at what is the slope of a line parallel to the graph of y equals 5x plus 4. So for instance, if my slope, if my equation is y equals 5x plus 4, a line that would be parallel to that, the slope would have the same, line that's parallel would have the same slope. So the slope of a new line would have another slope of 5. So a separate line would be y equals 5x plus 6, or y equals 5x minus 1. All those lines would be parallel because in each case the slope is 5. The slope of a perpendicular line, so a perpendicular line would have the opposite sign and the reciprocal. So the slope, the slope of the perpendicular line is going to be equal to negative 1/5. Okay? Alright, number 9. Okay, problem number 9. What is the slope of a line parallel to the graph of the linear function f of x equals negative 1/2 x minus 3? So here's your function, f of x is equal to negative 1/2 x minus 3. Okay? The slope that is parallel is going to have the same slope. So the slope of the parallel line is going to be equal to negative 1/2 as well. The slope of the perpendicular line, is going to be the opposite sign, so it's going to be positive, and that's going to be 2 over 1, or just 2. So there's problem number 9. Problem 10. Problem 10. So give an equation for each of the each line or function. So if you're given that a slope is equal to 2.5 and contains the point 8, 12. Point is 8, 12. We'll simply use the point slope form. So we would go y minus y1 is equal to m times the quantity x minus x1. So we'll replace y1 with 12 and x1 with 8. So I go y minus 12, and our slope is 2.5, so that's 2.5 times the quantity x minus 8. Done. Number 11. Here we're given the information that the point is 0, 2, and slope is negative 1. Okay, so we could go here. We could go y minus 2 is equal to negative 1 times the quantity x minus 0, which, by the way, would be y minus 2 is equal to negative 1x. And if I add 2 to both sides, I could go y is equal to negative x plus 2. So there's a couple different ways you could write that equation, and it would be correct. And that would be number 11. Okay, going on to number 12. Here I have the function evaluated at 2 equals 5 and has a y-intercept of 0. So y-intercept equals 0. So in actuality, we have 2 points here. If the function has x value, has a y value of 5, so we therefore have the point 2, 5, and we also have a point 0, 0. Right? So from here, we know then that our slope is going to be 5 minus 0 over 2 minus 0, or 5 halves. And I know my y-intercept is 0, so my equation is going to be y is equal to 5 halves x plus 0, or I could just write y is equal to 5 halves x. Okay, so there's 12. And 13, here you have the points, you have 2 points, you have 3, comma, 0.12. And you also have the point 8, comma, 0.045. 0.045. So it looks like we need to find slope. So we can go, let's see, so we have m is equal to 0.045 minus 0.12 over 8 minus 3. Okay, so if I look at my calculator, so if I go 0.045, so 0.045 minus 0.12, I get negative 0.075. So negative 0.075. And on the bottom, I have 8 minus 3, which is 5. So if I divide that by 5, my slope is equal to negative 0.015. Negative 0.015. Okay, so that's my slope. And I think probably the easiest way to do this would put it in point slope form. So I'm going to go y minus 0.12 is equal to negative 0.015 times the quantity x minus 3. And call that good for writing the equation of the line right there for number 13.